Have you ever logged into a website using your Google or Facebook account? Well, that's OAuth 2.0 in action. OAuth 2.0 is a security protocol that's everywhere online. It allows you to share your data from one website to another without ever sharing your password. In today's digital world, we rely on countless apps and websites. From social media to online shopping, these services often need to access our data from other platforms. OAuth 2.0 ensures this happens securely and with your consent. Think of it like a valet key. You give the valet limited access to your car, just enough to park it. OAuth 2.0 is similar. It lets you grant limited access to your data without handing over your master key, your password. In the following sections, we'll delve deeper into how OAuth 2.0 works, its benefits, and why it's crucial in our increasingly interconnected world. Imagine this, you're trying out a new recipe app. It asks to connect to your Google account to import your grocery list. In the past, you might have hesitated. Sharing your Google password with a third-party app felt risky. And rightly so. OAuth 2.0 solves this problem by providing a secure way to share specific data without exposing your password. It acts as an intermediary, obtaining your permission before granting limited access to the requesting app. Instead of handing over your keys, you're essentially giving the app a temporary pass. This pass allows access to specific data, like your grocery list, but nothing else. Your password remains safe with Google. This approach significantly enhances security. Even if the app were compromised, your Google account would remain protected. OAuth 2.0 ensures that you maintain control over your data and who can access it. Let's break down how OAuth 2.0 works using a relatable example: ordering food online. Imagine you're using a food delivery app to order dinner. You find a restaurant you like and proceed to checkout. The app needs your address to deliver the food. Instead of manually entering it, you see an option to sign in with Google. This is where OAuth 2.0 comes in. When you choose this option, the food delivery app, the client, redirects you to Google, the authorization server. Google asks you to log in, if you haven't already, and then shows you what information the food delivery app is requesting. In this case, it's just your address. You can review the request and choose to grant or deny access. If you grant access, Google sends a special token to the food delivery app, allowing it to retrieve your address. To fully grasp OAuth 2.0, it's crucial to understand the key players involved: client, authorization server, and resource server. The client is the app or website requesting access to your data. In our example, the food delivery app is the client. The authorization server is the service that holds your data and controls access to it. Google, in this case, is the authorization server. It verifies your identity and obtains your permission to share specific data. The resource server is the system where your data is stored. This could be Google Maps, which holds your address information. These three entities work together seamlessly to ensure secure and authorized data sharing. The client never directly interacts with your password or the resource server. All communication happens through the authorization server, acting as a trusted intermediary. Section 5, step-by-step how OAuth 2.0 works. Let's revisit our food delivery example and break down the OAuth 2.0 flow into simple steps. First, the food delivery app, which is the client, requests a token from the authorization server, in this case Google, to access your address. Next, you are redirected to Google's login page, where you enter your credentials. Then Google shows you what data the food delivery app is requesting, which is your address. You can choose to allow or deny access. If you grant access, Google sends a token back to the food delivery app. The food delivery app then uses the token to access your address from Google Maps, which acts as the resource server. With your address, the food delivery app completes your order and sends you delicious food. This process ensures that the food delivery app only receives the specific data it needs, your address, and nothing else. Your Google password is never shared, and you remain in control of your information. Section 6, diving deeper. Grant types in OAuth 2.0. OAuth 2.0 is a versatile protocol with different grant types tailored for various use cases. We've already seen the authorization code grant in our food delivery example. Now let's explore a few other common grant types. First, there's the implicit grant. This is used when the client is a browser-based application. It's less secure than the authorization code grant, but faster and suitable for situations where the client is considered trustworthy. Next, we have the Resource Owner Password Credentials Grant. As the name suggests, this involves the user providing their username and password directly to the client. It's generally discouraged due to security concerns and should only be used in specific scenarios with high trust levels. Lastly, there's the Client Credentials Grant. This is used when the client itself needs to access resources not on behalf of a user. This is often seen in machine-to-machine communication where user interaction isn't possible. Understanding these different grant types provides a deeper insight into how OAuth 2.0 adapts to various scenarios, ensuring secure data sharing across diverse applications. Section 7. Benefits of OAuth 2.0, Security and User Experience. OAuth 2.0 offers a compelling set of benefits, making it the go-to protocol for secure authorization and data sharing. OAuth 2.0 eliminates the need to share passwords with third-party apps, significantly reducing the risk of unauthorized access. Even if an app is compromised, your primary account remains secure. OAuth 2.0 simplifies the login process. Users can leverage their existing accounts from providers like Google or Facebook, eliminating the need to create and remember new credentials. OAuth 2.0 puts users in the driver's seat. You control which apps can access your data and what information they can access. This granular control empowers users and enhances privacy. OAuth 2.0 is widely adopted by major online platforms, making it a universal standard for secure authorization. This interoperability ensures a seamless experience across various websites and applications. Section 8. Potential pitfalls. Things to watch out for. While OAuth 2.0 offers robust security, it's not entirely foolproof. Here are a few potential pitfalls to be aware of. Malicious actors can create fake websites or apps that mimic legitimate ones, tricking users into handing over their credentials. Always double-check the website address and app details before entering your login information. OAuth 2.0 relies on tokens for authorization. If these tokens are not handled securely or expire, it can lead to vulnerabilities. Developers must implement proper token management practices to mitigate these risks. Some apps might request access to more data than necessary. It's crucial to review the requested permissions carefully before granting access. Only grant access to information that the app genuinely needs to function. By being aware of these potential pitfalls, users and developers can take necessary precautions to ensure the secure and responsible use of OAuth 2.0. Section 9. OAuth 2.0 in action. Real-world examples. OAuth 2.0 is ubiquitous in today's digital landscape. Here are a few real-world examples where it plays a vital role. Social login. As mentioned earlier, logging into websites and apps using your Google, Facebook, or Twitter account is a prime example of OAuth 2.0 in action. Cloud integrations. Connecting different cloud services like syncing your email with a CRM platform or integrating your calendar with a project management tool often relies on OAuth 2.0 for secure authorization. Mobile applications. Countless mobile apps, from fitness trackers to photo editors, utilize OAuth 2.0 to access your data from other services, enhancing their functionality and user experience. These examples highlight the pervasive nature of OAuth 2.0, demonstrating its significance in enabling secure and seamless data sharing across various platforms and applications. Section 10. Conclusion. OAuth 2.0 is essential in the digital age. In an increasingly interconnected world where data sharing is paramount, OAuth 2.0 has emerged as an indispensable protocol. It provides a robust and secure framework for authorizing access to our digital assets without compromising security. By understanding the basics of OAuth 2.0, you're empowered to make informed decisions about your online privacy and security. You can confidently utilize the convenience of social logins and app integrations while maintaining control over your data. As our reliance on digital services continues to grow, so too will the importance of secure authorization mechanisms like OAuth 2.0. It's a fundamental building block of a safer and more interconnected digital future. Section 11. Further learning resources to deepen your understanding. This guide has provided a foundational understanding of OAuth 2.0. If you're eager to delve deeper into the technical intricacies or explore advanced concepts, here are some valuable resources. The official website offers comprehensive documentation, specifications, and resources for developers and enthusiasts alike. This tutorial provides a hands-on approach to learning OAuth 2.0, guiding you through setting up and implementing the protocol. Auth0, a leading identity platform, offers insightful blog posts and detailed documentation on OAuth 2.0 and related security concepts. Continuous learning is crucial in the ever-evolving world of cybersecurity. By exploring these resources and staying informed, you can navigate the digital landscape confidently and securely.